All right, so we have already started with free damped system, and we have derived this governing differential equation for free damped system, and we have derived the equation for the governing differential equation. Then we solve this governing differential equation, and then we also uh, found the roots of this governing differential equation, and we identified three types of governing differential equation, that is over damped, under damped, and critically damped, depending upon the value of the damping ratio or damping factor, that is zeta is equal to 1, then the system is critically damped. When zeta is less than 1, then the system is under damped, and zeta is greater than 1, then the system is over damped. Okay, and we have also plotted the graph of all the four systems, including the undamped system which we have studied, and we superimpose the responses, and we studied the variation in various types of response in various types of system. Right, and we have started with the examples. We have finished three examples. Now we'll continue with the next example. Okay, so the question is, derive the equation of motion and find the natural frequency of vibration for each of the systems shown. Okay, so we'll first step is to draw the free body diagram. Free body diagram. Okay, and assume that at a given instance the wheel is rotating in clockwise direction. Right? This is your theta dot and theta double dot. Right? And the forces on this will be the spring force. So this whole thing is deflected by angular distance of theta. I have taken O as the instantaneous center, so angular deflection will be theta. This is theta. Right? So the forces in the system will be spring force, that will be, and if x is the displacement of the center, then it will be kx, and the damping force will be c into x dot. Alright, so that is your free body diagram. Next, you have to apply the D'Alembert's principle. So summation MO is equal to I0 theta double dot. Okay, and since I have taken shown the instantaneous rotation in clockwise direction, I am taking the convention clockwise positive. All right. So forces will be minus kx into r minus kx into r, and that will be negative because kx moment is in clockwise in anti-clockwise direction. I have taken clockwise positive, minus cx dot into r is equal to I 0 dot x dot into r is equal to I0. So I0 by parallel access theorem will be mr square by 2 plus mr square plus mr square. All right. So this is the I0. Substitute that is in the equation. So you get mr square by 2 plus mr square into theta double dot. That is the angular acceleration. Okay, so this is your free body diagram, and this is your equation. Okay. Next, we will arrange the terms in our familiar format, and before arranging it, we are going to convert the whole system in terms of theta, in terms of rotation. Okay. So x is r theta, so x dot is equal to r theta dot. So the equation becomes 3 by 2 m r square theta double dot plus CR square theta dot plus KR square theta is equal to 0. Okay, so this is in our familiar format, I equivalent theta double dot plus C torsional equivalent into theta dot plus K torsional equivalent into theta. That is equal to 0. All right. And so now you have to find the natural frequency. So find out omega n. So omega n will be K torsional equivalent divided by I equivalent. All right. So substitute the values and find out the value of omega n. Take K is equal to 3 Newton per meter and M is equal to 2 kgs. Substitute the value and answer the first quiz question. Okay, open up the quiz and the first quiz question is in the form of a fill in the blank. So answer that.
So can you please show the values again?
Which values? Values of
K,
K,
K, K.
K and M.
Yes, yes.
K is equal to K is 3 Newton per meter, M is 2 kg. Now, one instruction to all the students: do not submit the quiz immediately. Okay, submit it at the end of the lecture. Do not just answer one question and submit it. Right? You have to submit all the questions for the of the quiz, and then at the end of the lecture, then you are supposed to submit the quiz. Okay, so don't just submit the quiz without answering all the questions. I mean, you will not be able to submit the quiz. And if anybody just submits it, writing some random answers, then that will not be considered. That excuse will not be accepted. All right, you have a couple of minutes to solve this. Very simple question. Will not take you more than couple of minutes. So don't submit the quiz. You have to answer the remaining questions. Only after that you submit the quiz. Moving on to the next question. I hope everybody is able to answer that. All right. Next question. Derive the equation of motion and find the natural frequency of vibration for the system shown. All right. So first step will be always to construct the free body diagram. So I'm going to construct the free body diagram. Perpendicular. Give it a rotation. This is theta. So rotation in clockwise direction, theta, theta dot, theta double dot, angular velocity, acceleration, and displacement. Okay, and so forces will be, there will be, so this is x, and spring force will be kx, and also at the other end there will be spring force kx plus damping force cx dot. All right, so there are these two forces on the other side. Okay? Now apply the D'Alembert's principle, that is summation mo, that is this point O, is equal to I0 theta double dot. Right? So this is your governing differential equation, sorry, D'Alembert's principle equation and the free body diagram. Okay, now let's substitute all the values. So this will be minus kx into r minus kx into r minus 6x dot into r is equal to 3 by 2 m r square theta dot double dot. Okay, now I'm not again going to do that parallel axis again and again, because I'm going to take the mi about the base point for the disk, and that is always going to be 3 by 2 mr square. So let's remember that. Okay, and x is equal to r theta, x dot is equal to r theta dot, and substitute all the values in the equation. So that would be 3 by 2 mr square theta double dot plus cr square theta dot plus 2k r square theta is equal to 0. Okay, again this is of the form I equivalent theta double dot plus c torsional equivalent theta dot plus k torsional equivalent theta is equal to 0. Right? So find out omega n and take k is equal to 3 Newton per meter, m is equal to 1 kg, and answer the next quiz question. Okay? So find out omega n, take k is equal to 3 Newton per meter and m is equal to 1, and find out the natural frequency of the system. And again it is a fill in the blank. Okay, when you are writing the answers, please follow these rules. Huh? That is for the first quiz, for all the answers also. Your answer should be without decimal. Okay, so you should write the answer by rounding it off to the nearest possible whole number. Okay, so for example, if your answer is 6.1, then ignore the term after the decimal and just write the answer as 6. Okay, do not write the units. See, units are already mentioned in the question, so you don't have to write the units in your answer. Just write the number and submit. Don't submit it now. Just write the number, whole number, and keep it. So suppose instead of 6.1, your answer is 6.8. Then you have to round off to the nearest possible whole number. So now in this case, the answer will be 7. Okay. Don't write 7.0. Okay, or 6.0. You have to just write the answer without decimal. Okay. So write it. Your answer should be either 6, 7, or whatever is the whatever comes out from your calculation. Okay, again there are, I give you two more minutes.
Sir, could you just show the values again?
Just a minute. Everybody has got the question sheet, na?
Okay, sir, got it.
No, I am asking, has everybody received the PDF for the question sheet? Gaurav?
Yes, sir, they have.
Okay. Can write the answer in form of whole number. Please don't make mistake in writing the answer in correct format. I will just write the values on the next sheet also. K is equal to K is equal to 3 Newton per meter, M is equal to 1. K is equal to 3 Newton per meter and M is equal to 1 kg. Right? So these are the values. This is the data for the question. One more minute. After that, I'm going to continue. All right. Let's continue to the next question. Derive the equation of motion and find the natural frequency of vibration for the system shown. Okay, so this is the system. So first step always will be to construct a free body diagram. So let's construct a free body diagram. So the whole system is pivoted about O. All right. So I'm going to give a displacement of theta in counterclockwise direction. So this is in counterclockwise direction. So this is your theta, theta dot, and theta double dot. All right. So now find out the forces in each of the elements. So here it will be so here again the displacement of spring 3K will be X. Okay. So force will be 3K into X. Deflection of the damper, since both, see this is L by 4 and also the damper is also attached at L by 4. So both are equidistant from the pivot O. So this also will be X. And the damping force, now the motion is in upward direction, so damper always opposes the motion. So damping force now will be Cx dot and it is acting downwards. Okay. Now this spring is getting expanded. There is extension to the spring. This spring is getting compressed. So again the spring force will be again for the second K spring will be again in downward direction. And for this one the displacement is x1. This displacement is 1. So spring force will be acting downward and that will be K x1. All right. So that is your free body diagram. Okay. After you get the free body diagram, next step will be to apply the D'Alembert space. So this is your free body. I have reconstructed the free body diagram again with all the forces, and this is your pivot O. Right. So let me write the D'Alembert's equation. So summation M about O is equal to I about O into theta double dot. That is the angular axis. And since I have taken anti-clockwise positive, I am going to use that convention. So anti-clockwise will be positive. All right. Now write down the moment of all the forces. So first one is the 3k spring. So minus 3k is 3k x into L by 4 minus Tx dot into L by 4 minus kx1 into L by 2 plus L by 4. So that is equal to, this is 3L by 4, right, is equal to I0 theta double dot. So x is equal to L by 4 times theta. So x dot will be L by 4 times theta dot, and x1 will be 3L by 4 into theta. Alright. So substitute all the values in the equation. So I get minus 3k into L square by 16 times theta minus C L square theta dot minus LCL square theta dot divided by 16 minus 9k L square theta divided by 16 is equal to I0 theta double dot. Okay. So that is my equation. This is my governing differential equation. Right. So this is my governing, and I am going to rearrange the term and write it in our familiar format. So our familiar format, everything is on the left hand side. So I0 theta double dot plus CL square by 16 theta dot plus 3 by 4 KL square theta is equal to 0, which is of our familiar format, I equivalent into theta double dot plus C torsional equivalent C torsional equivalent into theta dot plus A torsional equivalent into theta is equal to 0. So omega n is equal to K torsional equivalent K torsional equivalent divided by I equivalent. Okay. Now compare the terms in the equation and find out what is K torsional equivalent, find out what is I equivalent. Okay. Take K is equal to 7 Newton per meter, mass is equal to 1 kg, and answer the quiz question. So K is 7 Newton per meter and M is equal to 1 kg. 1 kg. So take these values and calculate and enter the values in your blank space provided in your fill in the blank. Again, this is slightly more intense. I will give you 1 minute, 1 or 2 minutes extra. Again, I am repeating, do not submit it at the end. You will not be able to submit it unless all the quiz questions are answered. All right, time is up. Let's go to the next question. All right. All right. Again. So here you are required to find C. So C is what? It is denotation for damping coefficient. That is force per unit speed. That is unit will be Newton second per meter. All right. So you have to require to find the damping coefficient C for this arrangement shown. And so first of all, let's draw the free body diagram. Okay, so let's first construct the free body diagram. Okay. Now again, I'm assuming that the instantaneous displacement is in counterclockwise direction. So this angular displacement is theta. Right. So this distance at the top. So this will be. So if this is, say, let's call this as. So this will be r theta, and this will be 2r theta. Okay. And
So we are only able to see the question.
yes, I am. Are you not able to see the free body diagram?
No, no,
Yes.
no, sir.
Yes, sir, we are able to.
There must be some lag in your. How about others? Are you able to see the diagram which I am constructing with the orange ink? Gaurav?
Yes, sir. Now it's visible.
Yes, sir.
Okay. All right. So this displacement is r theta, and the one on the top will be 2r theta. Radius is given as r. The radius of this wheel is given as r. Okay. Now x1 is the deflection in spring. Okay. So deflection in spring is x1. So the spring force will be a x1. All right. And since it is a smooth pulley, this is a smooth pulley. Force on both the sides of the pulley have to be same. So this is top one is kx1, and the lower one attached to the other end of the spring is also kx1. So this is also kx1. All right. So this is the spring force, and it is in opposite direction to the displacement assumed. Right? It opposes the displacement. All right. And x2. So what is x1? Deflection in spring. Okay. So deflection, now this spring is getting pulled from both the sides. All right. So on the one end it is stretched by 2r theta. On the other end it is stretched by r theta. So x1, the deflection in spring will be 2r theta plus r theta. So that becomes equal to 3r theta. All right. Now the displacement of damper, so x2, let this be the displacement of damper. And that is equal to x2, and that is equal to r theta. All right. So
Can you
here,
explain again how 3r
see,
theta?
this is the spring. When I give this angular displacement theta, all right, the spring is getting pulled from both the sides. So the topmost point moves by 2r theta, right? And the center moves by r theta. Okay, and both these points are pulling the spring in opposite direction. All right. So the top point moves by 2r theta, the lower point moves by 2r theta. So the spring, in fact, is stretched by on both sides.
Okay, okay. Okay.
All right.
Is that string pivoted at the center?
The spring is
String?
attached.
Cord.
Cord is attached at the center.
Okay, okay.
That is how the diagram is, no? It is attached. One end is attached at the top, and the other end is attached at the center. Is that clear? All right.
Yes,
Shall I
yes.
proceed? Okay.
Yes.
So x1 is 3r theta, and x2, that is the displacement of the damper, is r theta. All right. So the damping force will be again in opposite direction to the displacement, but now the damping force will be c into x2 dot. That is the velocity. All right. So x2 is r theta. So x2 dot will be r theta dot. X2 dot is r theta dot. All right. So that is your free body diagram. So that is just I am again displayed the same diagram. All right. So this is how you construct the free body diagram. Minus k into x1 times r minus cx2 dot into r is equal to I theta double dot. I theta double dot. Okay. So I theta double dot plus c r square theta dot plus hello. Hello, are you able to see the screen?
Yes, sir. Yes, sir.
There are some
Yes,
slight
sir.
Now we can.
some interruption. Somebody was trying to call, I don't know why. All right, so I theta double dot plus C R square theta dot plus 3K into 3 R theta into R is equal to 0. All right, so that becomes I theta double dot plus C R square theta dot plus 9K R square theta is equal to 0. All right, so again, this is in our familiar format. It is I equivalent into theta double dot plus C torsional equivalent into theta dot plus K torsional equivalent into theta is equal to 0. All right. So now here I equivalent is again 3 by 2 mr square because it is a disk. C torsional equivalent will be CR square and K torsional equivalent will be 9K R square. All right. So C torsional critical will be equal to 2 into square root of I equivalent into K torsional equivalent. All right. That is your similar format. That is 2 into square root of K by K into M. Okay. So this is your critical torsional coefficient. All right. So C torsional critical becomes 2 into square root of 3 by 2 m r square times 9K R square is equal to 7.348 R square into square root of K dot M. Okay. Now C torsional equivalent by C torsional critical, that is equal to 0.2. That is given. All right, the damping ratio is given. Okay, so that gives you C. So C torsional equivalent is nothing but CR square. So that is equal to 0.2 into 7.348. 7.348 into R square into root K times M. So C is equal to 1.47 into square root of K times M. Now you can also solve this equation by energy method. Okay. So let's try solve this by energy method. All right. So by energy method, that is kinetic energy plus potential energy is equal to constant. So half I 0 theta dot square plus half K into x1 square plus the energy stored in the damper, potential energy stored in the damper, that is equal to damping force Fd into the displacement, infinitesimal displacement dx and integral of that. Now here in our case, the damping force is nothing but Cx2 dot since our variable x is replaced by x2, so dx will be replaced by dx2. Okay, so dx will be replaced by dx2. Okay. So this is your kinetic energy and this is your potential energy. Alright. So potential energy, so I substitute this, so I write half I theta dot square plus half k into x1 is 3r theta whole square r theta whole square plus integral of c integral of c x2 dot into d times x2 is equal to constant. All right. So that becomes, and x2 is r theta. So substitute that in the equation. So I get half I0 theta dot square plus half 9k r square theta square plus integral c r theta dot times r d r d theta, because x2 is r theta, so dx2 will be r d theta is equal to constant. Okay. So again the first two terms will remain the same. The last term I am going to take c r square out and theta dot remains inside the integral, and d theta I am going to write it as d theta by dt times, because I want to integrate it with respect to time. Okay, because all the other variables are the theta dot is a derivative with respect to time, theta is the displacement with respect to time. Okay. So this becomes again constant. Now again the first two terms remain same, and the third term can now be written as c r square theta dot square into d, and that is equal to constant. Right? Right? So this is what I want in the form. Now after I write the equation of kinetic energy plus potential energy, next step will be to differentiate. Okay, to differentiate this equation. All right. So this first term becomes I theta dot theta double dot. This one becomes theta theta dot, and it is twice. So this half gets cancelled. And when I differentiate this term, simply what happens is that the integral sign will disappear, and what remains is the just the theta square. Okay. So once I differentiate this equation, I get the first term will be I theta double dot. The integral term, this becomes c r square theta dot, and the stiffness term becomes 9 kr square theta, and this right hand side is constant, so this becomes equal to 0. So again we get the same governing difference. All right, you have a couple of minutes to answer the question. Yes, anybody has any questions? You have to choose the correct statement. All right, I hope everybody's done. We'll move on to the next question. There is no calculation in this. You have to just select based on whatever calculation we have done. All right. So last question of the lecture today. So I will just read the question. A heavy door along with a door closing system is shown in the figure. The moment of inertia of the panel about the hinge axis is 20 kg meter square. So more directly, the moment about the hinge is given. Okay, and it is 20 kg meter square. The stiffness of the torsional spring is 25 Newton meter. So KT is 25 Newton meter per radian. Find out the most suitable value of the damping coefficient C. Neglect the inclination effect. A is given as 10 centimeters. I hope everybody has the question. So first step, draw the free body diagram. This is Cx dot. This is A, and this is pivoted about hinge. Right. There is this torsional spring moment, and the displacement is given in clockwise direction. So this is your theta, theta dot, and theta double dot. Okay, so apply D'Alembert's principle. Summation m is equal to I theta double dot. So minus k torsional theta, that is the torsional moment due to the spring, minus Cx dot into A is equal to I theta double dot. Okay, so x is equal to A theta, x dot is equal to A theta dot. So substitute that and rearrange the equation. So the equation becomes I theta double dot, I theta double dot plus Ca square theta dot plus K torsional theta is equal to 0. Okay. So again, this becomes of our similar format. So that is I equivalent theta double dot plus C torsional equivalent theta dot plus K torsional theta. T torsional equivalent is nothing but A square into C. Okay. So the system is critically damped. So for critically damped system, C torsional equivalent is equal to C torsional critical. All right. So C torsional equivalent is C torsional critical because the system is critically damped. So zeta is equal to 1. So C torsional equivalent becomes C torsional critical. So C torsional critical is equal to C torsional equivalent is equal to 2 into square root of I equivalent into K torsional equivalent. So you know what are the values of I equivalent? What is the value of K equivalent? Value of KT is given, value of I is also given. Substitute in the equation and use the equation for C torsional equivalent and find out the damping coefficient. Find the damping coefficient and substitute your answer. All right, so you have 5 minutes till the end of the lecture to close to answer this quiz. And if anybody has any questions, please go ahead and ask. And meanwhile, I forget. Any questions you have, please ask. Now, after you answer this question, you please submit the quiz. Again, write the answer without unit. The unit is already mentioned in the question. Okay, it is Newton second per meter. So do not write the unit in the question, just plainly write the answer and submit it. Again, you are supposed to round it off. Write the answer without decimal by rounding off it to the nearest possible whole number. Do not write the units. For example, again I am going to tell you, if the answer is 3.1, then your answer should be 3. Okay. If your answer is 3.8, then round it off to nearest whole number, that will be 4. So your answer will be 4. Okay. So this is how you have to write the answer. Any questions? Any other questions for today's session? Have you received the quiz scores for all the previous quizzes? I have posted all the scores for all the previous quizzes. Has everybody received it? Gaurav?
Yes, sir. We can see the answers now.
Yeah, means the points and answers you should be able to see. Whether it is correct or wrong, whatever it is. Feedback you should be able to see. You have 2 more minutes before we close the quiz. All of you submit your responses fast. All right, I'm closing the quiz. Submit your responses. All right, I'm closing the quiz now. Submit your responses. Otherwise, you will not be able to get the score. All right, I've closed the responses now. All right, scores are posted. That's all for today's lecture. Thank you. Unless anybody has any questions, I will end the lecture.
Thank you, sir.
Thank you. Okay, thank you. Bye.